everyone. Myself Muthumari, working as Assistant Professor of Mathematics in SFR College for Women, Sivakasi. In this lecture, we are going to see about the concept of uniform continuity in real analysis. You are all very familiar about continuous function. I hope in previous classes you might have seen about a lot of properties about continuous function. In this lecture, we are going to seeing about uniform continuity. So, before enter into the definition of uniform continuity, let us recall about the concept of continuity. So, to check the continuous function between two metric spaces M1 and M2, first we are going to choose a point in the domain at which we are going to check about the continuity of a function and a small quantity epsilon greater than 0 corresponding to this point and epsilon, if we can able to find a delta in such a way that it should satisfy the following conditions. That is, the distance between x and x naught less than delta implies the distance between f of x and f of x naught less than epsilon. So, whenever this happens for all epsilon greater than 0 and the corresponding point, then we say that the function is continuous at the point x naught. So, this property satisfied, then we say that the continuous function at x naught. Next, in uniform continuity, we are checking about the concept of continuous function in whole domain. So, to check the uniform continuity of a function, first let us define a function f from the metric space M1 to M2 and we are going to check the continuity in whole domain. So, for that we are choosing epsilon greater than 0 and corresponding to this epsilon, if we can able to find a delta, a quantity delta such that the distance between x and y less than delta implies the distance between f of x and f of y less than epsilon. If this condition holds, then we say that the function is uniformly continuous in the whole domain. So, the difference between the continuous and the uniform continuous is nothing but in continuity the value delta depends on the point x naught and epsilon, but in the uniform continuity the function, the point, the quantity epsilon, delta depends only on the value epsilon. So, in this lecture we are going to seeing about the concept of uniform continuity and the comparison between point-wise continuity and uniform continuity, and finally we are going to discuss about its properties and applications. Yes, uniform continuity is a powerful concept in real analysis. It describes functions that maintain a consistent level of continuity across their entire domain regardless of the distance between points. This is a mathematical definition of uniform continuity. A function from M1 to M2, here M1, M2 are metric spaces with the corresponding metrics D1 and D2 is uniformly continuous on M1. For a given epsilon, we can find delta such that the distance between f of x and f of y less than epsilon whenever the distance between x and y is less than delta. This condition should hold for all x and y in the domain. As I said, here the value delta depends upon the points x and y as well as the point x and y itself, whereas in the continuity the delta depends on the point x naught as well as the epsilon itself. Next, here are some examples of uniform continuous. Any linear function is uniformly continuous on the entire real line. So, in this example we can easily verify the definition of uniform continuity. Next example is the function we define f from closed interval 0, 1 to r by f of x equal to x square is uniformly continuous on the closed interval 0, 1 and any trigonometrical function is uniformly continuous is the next one example, and the constant multiple of the function f of x equal to kx is uniformly continuous. In all the examples we can check the uniform continuity of a function through definition itself. Next one, every from the definition we can clearly see about that every continuous uniformly continuous function is continuous, but the converse is not true always, but continuous functions becomes uniformly continuous in the closed and bounded domain. In general, every continuous function defined on a compact set is uniformly continuous. So, it is a famous, is a very important criterion also to become a continuous function becomes uniformly continuous. Next one is the relation between uniformly continuous and point-wise continuous. So, this is also I have already defined, discussed in the very earlier. A function is a point-wise continuous if it is continuous at each point in this domain, whereas in the uniform continuity is a stronger condition than point-wise continuity, requiring a consistent level of continuity across the entire domain. Next, uniformly, these are the properties of uniformly continuous. Uniform continuity on a bounded interval guarantees the boundedness of the function. If f is uniformly continuous and g is continuous, then the composition g composition f is also uniformly continuous on the same domain. Next, if I am taking a sequence of uniformly continuous function converging to some function, then that converging point, that function is also uniformly continuous. If f is uniformly continuous on the closed interval, then the integral of f, that interval can be approximated uniformly by a Riemann sums. Next, there are many applications of uniformly continuity exist. Here are some applications I quoted. The first one is differential equations, next numerical analysis and functional analysis. In differential equations, uniform continuity is essential for providing the existence and uniqueness of solutions to differential equations. In numerical analysis, uniform continuity is used to numerical analysis to develop accurate methods for approximating, integrating and solving equations. Also, uniformly continuous plays a crucial role in studying the properties of function spaces such as completeness and compactness as well as connectedness also. Uniform continuity plays a role in a fixed point theorem such as the Banach's fixed point theorem, which applies to contraction mappings in complete metric spaces. In general metric spaces, uniform continuity helps characterize the behavior of functions and allows for the extension of certain theorems from real analysis to more abstract settings. Thank you.